Okay guys, so now let's do the problem and we'll find out what are the exclusive features of doing FFT. So the question is as follows. You have your question that is given over there. So the question is like using FFT, compute DFT of x of n 1, 2, 3, 4. And we already have done this problem. We know that the answer is 10 minus 2 plus 2j minus 2 and minus 2 minus 2j. So I'll repeat, the question is find DFT of 1, 2, 3, 4 and the answer is 10 minus 2 plus 2j minus 2 minus 2 minus 2j. That is the answer. So we have to write this particular, solve this particular problem. So let's go for the concepts that we have learned earlier and see how it works out. First you have to determine n. So as per the question given to you, it is a 4-point DFT. If not specifically given to you, just refer the number of inputs terms in the input signal, and here you can see that n is 4. And the next factor that you need to determine is m equal to the number of stages. So the number of stages is 2, because you know that the relation between m and capital N is given by this 2 raised to m is equal to capital N. So since n is 4, m will be equal to 2. So that will be 2 stages. And the order of the stages. The last stage will be n point. So here n is 4, so this will be 4 point. And before that you will have a stage that is n by 2, which is 2 point. So you have two different options. One is 2 different stages, 2-point DFT and 4-point DFT. The ultimate or the last stage will be 2-point DFT itself. So this will be done 2 raised to 0 times, that will be done 1 time, and this will be done 2 raised to 1 time, that means it will be done 2 times. So 2-point DFT will be done 2 times over there, and 4-point DFT will be done 1 time. Now, what do you mean by a 2-point DFT? Is essentially the butterfly operation that you are going to perform, and here it means that it will be performed 2 times, and here it will be done. A 4-point butterfly will be done 1 time over there, but then that butterfly will involve 2 steps. We'll look into the case later. Now we know the butterfly diagram that is to be applied. So here it will be AB, and here it will be W and K, and here you have minus 1. So the butterfly to be applied is A plus B, W and K, and A minus B, W and K. That will be the butterfly under use. And then you have to determine the twiddle factors. So the one stage here is 4 point. So it will be W402, W41. So this will be 1, and which will be W40, and W41 will be minus sign that we have already found out. And for 2-point DFT, the twiddle factor required is W20 and to be equal to 1. Now the last step that you need to do is you need to write the things in the bit reversed order, and you have 3 inputs x of 0, 1, 2 and 3. The position will be returned in the binary order. It's not the value, it is a position that I'm writing. Please keep that in mind. Be reversed, x of 0, 1, 0, 0, 1 and 1, 1. So it will be x of 0, x of 2, x of 1 and x of 2. So now that is the case over here. You have the input written in the bit reversed order, and with this we can start doing the problem. Now you have the input written in the bit reversed order. So our input here is 1, 2, 3, 4, which would have corresponded to x of 0 equal to 1, x of 1 equal to 2, x of 2 equal to 3 and x of 3 equal to 4. So since this is bit reversed, this will be 1, this will be 3, this will be 2 and this will be 4. So I have written my input in the bit reversed order over here. As you see over here, the input is written in the bit reversed order 1, 3, 2, 4. And then I have to start doing the operation. Now what I have drawn here is I have drawn 4 lines corresponding to each of the input signals. So here there are 4, so I have drawn 4 lines, and I have drawn these broken lines to indicate each stage of the operation. So this corresponds to 2-point DFT, and this corresponds to 4-point DFT that is to be performed as per the logic here. So what happens here is we need to perform the butterfly diagram, and I'll be doing the stage 1 butterfly over here. So I'll be combining these two, and I'll be combining these two. So this is what happens here. I have mentioned that the 2-point DFTs will be done 2 times, and it is done, and that single butterfly solution can be referred to as a 2-point operation, and it will be done 2 times over here. So you can see one and the second one over here. Now this, you need to identify, to perform the operation you need to have 2 particulars, that is the twiddle factor and the -1 factor. So I am writing it down. So here it will be W20. So I am writing it as the twiddle factor will be here as the butterfly diagram that we have learned earlier, and the twiddle factor in this particular stage will be W20. Similarly, you will be having -1 over here, and the twiddle factor here also will be W20, because we have already learned that twiddle factor used for a 2-point DFT will be W20 only. So this is the only twiddle factor over here, and we are using that particular problem. So we have will be performing the operation right now. So just like the butterfly logic over here, you can understand that A is replaced with 1 and B is replaced with 3. So this over here will be A plus 3 W20, and here it will be A minus 3 W20. So this will be A plus 3 will be and W20 is 1, which we have written over here, so it is same. So 1 plus 3 will be equal to 4, and 1 minus 3 will be equal to -2. Similarly, when we operate these two signals, the signal here will be 2 minus 4 W20, sorry, 2 plus 4 W20, and here it will be 2 minus 4 W20. So this will be equal to 6, and this will be equal to -2. Again, because of the factor W20 equal to 1, this operation is clear. So output of the first stage is 4, -2, 6, and -2. So your first stage is over, and now you have to perform the second stage. So to perform the second stage, what happens here is you are combining the output of these two previous stage. You are combining the 2 previous outputs of the previous stage, and you have 2 different butterflies. So what you do here is you connect the top arm of the first butterfly with the top arm of the second butterfly. So this is the graph. Okay, you connect the top arms of both the butterfly, and this will be the first butterfly of this 4-point DFT, and then you have to connect the bottom arms of the 2 butterflies. So if you look over here, this a 4-point DFT is done only once, but it has got 2 butterflies. I hope that point is clear. A 4-point DFT is done only one time, but it will have 2 butterflies, which will be using the twiddle factor W40 and the twiddle factor W41. So this will be like you have -1 here and you have -1 here, the other factor. So when we look at this butterfly operation, we have to do it correctly, so please be careful. So the first butterfly, I am solving it. So this will be 4 plus 6 W40, and here it will be 4 minus 6 W40. Here it will be -2 plus -2 W41, and here it will be -2 plus, sorry, -2 minus, I repeat, sorry, -2 minus of -2 W41. So when we compute this particular thing, this W40 is 1 essentially, so this will be 10, and this will be 0, this W40 is 1, so this will be -2. While this becomes -2 plus -2 W41, so W41 is -I, so when you substitute it over here, this becomes -2 plus 2i, and over here it becomes minus 2 of minus 2i. So now we got the output, which is again the output that we decide, because we already have done this problem using the formula method. That is, by solving this you get 10 minus 2 plus 2j minus 2 and minus 2 minus 2j, and you get the same answer here. So y of n is obtained here, 10 minus 2 plus 2j minus 2 and minus 2 minus 2j. So you have solved a 4-point DFT using FFT method. The other point to be noted here is the fact that even though you had written your input in the bit reversed order, your output that you got is in the correct order. So we already know the answer for this particular problem, so that must not be a concern for you. But if you're doing a fresh problem and you need to know what is the answer, then it should be clear that the answer that you get at the end, it is in the correct order, and it should be done in the written in the correct order itself. For the case of DIF, it is a bit different, which is why I explained this right now.